Perfect.
So good afternoon, everybody. My name is Cale Harbor. I'm the product manager with Advanced Control Solutions, and I'm very pleased to be able to invite Robotiq with us today, who is going to be going over the details regarding their new CNC machine tending kit and how their products can help get a CNC machine tending system up and running quickly and easily. So with that, we're going to start off with Mr. Tyler Mays. Tyler, would you introduce yourself to everybody?
Will do. Thank you very much, Cale, and thank you everyone for attending this afternoon. My name is Tyler Mays, and I'm your channel sales manager with Robotiq. I'm based just outside of Philadelphia, Pennsylvania, and I cover the eastern United States. Today, I will be talking to you about a little bit of background about Robotiq, who we are and where we came from. And I will also be answering the question, why machine tending? So why are we focusing on machine tending as our application of choice? Today, we also have the pleasure of having Mark Antoine present to us. Mark, would you go ahead and introduce yourself as well?
Yeah, sure. Hi, everyone. It's a pleasure to be here with you today. So basically, I'm an integration coach. So we're two integration coach for all the North America. So we focus on pretty much North America territory. So if you have any technical question, application focus question, we're here to help you with that.
Very good. Thank you, Mark.
So, hey, Tyler.
Yes.
Real quick, I did want to point out I'm going to be moderating and watching the chat room. So if anyone has questions during the presentation, please post it to the chat, and I'll make sure to get it to the correct person to get everybody answered this afternoon.
Thank you very much, Cale. And for all those attending, I'll be able to share our contact information with you. But if you do have any other questions, whether it's now during the webinar or if any questions pop up afterwards, please reach out to your contact at ACS, and they'll be able to best direct you towards the resource that you need. All right, so a little bit of background on Robotiq. We were founded back in 2008 with the company mission being to free human hands from repetitive tasks. That, in essence, means that we're trying to take care of the dirty, dull, and dangerous tasks that plague manufacturing and really make it hard for folks to enjoy the work that they're doing. By freeing those human hands, we're actually able to free up our human workers to do more value-added tasks. So what our focus is to help manufacturers overcome their workforce challenges by enabling them to install robots on their own. And so in this particular presentation, we're going to focus on doing CNC machine tending application with cobots, but there are many, many more, and I encourage you to talk with your friends at ACS about those as well. So basically what we do is we use an approach we call lean robotics to look at what an automation cell consists of. And what we do know for sure is that the challenge is never the robot. Robots are very well built, they're good at what they do, and they do exactly what they're told to do. But when we're looking at the cobot cell in our image down here on the bottom left side of the screen, you see that there are a whole bunch of other factors that really determine whether or not an application is going to be a success. So what we do at Robotiq is manufacture hardware and software solutions to help make all of those challenges in a cobot cell easier. We make grippers, cameras, vacuum grippers, force torque sensing software and hardware, productivity monitoring hardware, etc. There's a whole lot of things that are on our catalog. But today's question, why a CNC machine tending kit, is one that I aim to answer. So is it CNC or else? Traditionally, CNC machine tending has been the best selling application both for universal robots as well as Robotiq. It makes up probably about 40% of the cobot deployments that we see today. We've been able to take that knowledge and expertise and the field experience combined with the customer feedbacks to help us really understand and determine what it takes to have a successful CNC machine tending cell. In the image you see here, this is actually from almost 10 years ago at this point, but you see an ABB industrial robot and also our Robotiq 3-finger gripper. This is a very early deployment of robotics for CNC machine tending, but I'll be honest with you, this is something that proved to be a whole pain point for us because, quite frankly, industrial robots are not a good fit for this application. Something else that plagues CNC machine shops or any manufacturing facility that utilizes CNC machines is the idea of finding and retaining good help. In just about every CNC shop you drive by, they probably have an help wanted sign in the window, and that's for good reason. It's hard to find good help. It's also hard to keep good help, and it can also be expensive. I've got a little bit of information here for salaries for CNC machinists. This is in Minneapolis, Minnesota. It's about around 75,000 average. In Los Angeles, California, it's up towards 90,000. Or in Fort Worth, Texas, it's back around that $75,000 mark. Whatever it is for you in your area, obviously a CNC machinist can be expensive. With that in mind, we want to make sure that we're utilizing our employees to their full potential and making sure that a CNC machinist is not doing something that's non-value added, like sitting and waiting for parts uh, to be finished on the machine. We want to make sure that they're doing what they like to do, and setting up CNC machines, writing programs, etc. The whole concept and the goal for CNC machine tending is this idea of keeping the spindle running. When the spindles are running, the machines are generating revenue, and we know that downtime is the enemy of every CNC shop. So from those early days in that picture of the ABB industrial robot and the Robotiq 3-finger gripper, we've seen a number of problems that can arise in a CNC machine tending application. Lack of reliability, the need for fast changeover, a high payload capacity, and also a knowledge gap that comes with a CNC operator not necessarily being able to program an industrial robot. So to address the lack of reliability concern, Robotiq has created a gripper that is sealed, IP67 rated. We're able to confirm the presence of a part within our grasp, and we're able to regrasp if needed. In terms of the force sensing capabilities, we're able to use the force torque sensor in the robot and Robotiq's Force Copilot software to do a precise insertion. And we're also able to find surfaces. So something that you'll see in a few minutes here, once Marc-Antoine is doing his demonstration, is that we can find surfaces like a vise, for example, and know where to load our parts accordingly. In terms of the need for fast changeover, what our goal is with the CNC machine tending kit is to eliminate the need for complex or expensive fixtures. So for the robot to the machine cell, we're actually able to use something we call contact offset, which is going to be demonstrated here in a few minutes, to touch off multiple points on the vise and determine its orientation and where the robot is oriented in relation to that vise. And we're able to adjust the program automatically according to where that vice's position is. We're also able to use visual offset on a tray of parts, for example, in this image, where we use our wrist camera and scan that checkerboard tag. And once we see that, we're actually able to determine the orientation of whatever surface that tag is on. So whether it's a tray of parts, we know where all those parts are going to be. If that tag is on the CNC machine, we know where the robot is in relation to the machine. And if that tag is on the vise, we know where the robot's at compared to the vise, so on and so forth. So these two features here are eliminating a lot of complexity and expense. For the capacity needs, you're able to run a dual gripper configuration with Robotiq's products. In fact, our CNC machine tending kit features 2 grippers. Each of those has a 5-kilogram payload per gripper, and they're also easily customizable with custom fingertips or modifying the stroke with custom fingertips, etc. Those things might not make a ton of sense right now as we just look at this image, but as you talk through your application with your contact over at ACS, these things will become more apparent. Finally, addressing the knowledge gap, something that is certainly one of the biggest concerns in terms of deploying a new cobot. Robotiq has a ton of free resources available, and so does ACS, including our e-learning online platform, where you can learn how to communicate with the CNC machine, how to do handshake I/O between your cobot and your machine. We help you on how to design custom fingertips for your grippers, and also how to set a TCP, or a tool center point. That is a key piece of information that's needed to create a robot program. So what is the CNC machine tending kit from Robotiq? It includes a dual handy configuration, which you can see here. We've got multiple fingertips that come in that package, as well as the fingertip extenders to give you additional stroke if needed. The Machine Tending Copilot is the force torque sensing software, which we use to do the contact offset, which we discussed, to do a part insertion into a vise, etc. Any sense of touch that your robot needs to perform its task, that's what Machine Tending Copilot brings to the table. We also have the Robotiq camera, which is actually very sleek. It's the only camera that's designed specifically for use with universal robots. And you can see here in this picture just how sleek it is. It's also IP67 rated, so it's ready for the coolant and industrial environment, which a CNC machine tending application is. And this wrist camera is fantastic for doing part detection. So if you're not loading your parts into trays, if you're just putting them on the tabletop, our camera will find and help the robot pick them. We're able to do that visual offset scanning. We're able to scan barcodes and much, much more. So again, all of this information and more is available on Robotiq's e-learning platform, which your friends at ACS will share a link with you later. All right, all that being said, I'm going to take a brief pause to take any questions, if any have arisen so far. And if not, I'm going to hand it over to Marc-Antoine so he can do a presentation of Robotiq's CNC Machine Tending Kit.
At this point, there are no questions that have come in the chat room, so I think we're good to keep going.
All right, perfect. Now, for all those in attendance, we're going to be presenting robot programming at what I would consider a medium or intermediate level. We're operating under the assumption that you know a little bit about the basics of how a robot works, how a gripper works, etc. If that is something that you're not familiar with at this time, I strongly recommend checking out Robotiq's e-learning page and also working with your friends over at ACS to find a webinar to learn those basics, or also sign up for their seminars. Hopefully we can resume some of our great seminars in person here soon. All right, that being said, I'm going to go ahead and stop sharing my screen, and Marc-Antoine, go ahead and take over.
Thank you, Tyler. So before we jump into the demo per se, I just wanted to do a quick stop since Tyler was talking about the e-learning platform. So I just wanted to show it to you really quickly. If you go on our website, so there's two things. So there's the e-learning platform, but there's also the configurator. So another one that I wanted to show you. So we got here on our website, so either into resources, we have the e-learning platform. And then we have here on the product configurator. So if I click on this one, it's basically a platform where you can visualize the Robotiq products. So for example, if you want to see the two-finger grippers, the handy grippers, if you want to see a full stack with the force torque sensor, the camera, and the gripper. So that's a platform where you can visualize the product and play with it. As you can see, there's vacuum grippers, there's the sensing, and there's the application kit. You can see dual gripper as well. If you go on the right side in here, so there are a few sections. We got the video. So these are basically a case study that we have and video on our product to show you how it works in real life. We got the e-learning, we got the e-books. So these are kind of, I would say, is book to how to design and integrate a robotic cell. And then we have the documentation on the specific products. So these are basically the operation manual that you can find again on our website. So if we jump into the e-learning platform, so for example, Copilot, I'm gonna go straight to the main page actually. So as you can see, there's Lean Robotic Basics, application and products. So you can browse into these one, and what you're gonna get are basically these courses. So for example, we could go into Machine Tending application kit. So this one is, as Tyler was mentioning, it may be medium or advanced features for you guys, but everything is in there. So you can start with the adaptive gripper and everything will be in there. There's few courses, few lessons with a short video, for example, 5 to 10 minutes videos, and the same thing with the Machine Tending. So as you can see, there's a lot of course in there that you can follow and have, as you can see, green checkbox, so really follow your how you're going into your course, so you keep the tracking of everything you're doing. So please refer to that if you have any further question or if you need to learn more about Robotiq. That being said, if we jump back into the the demo. So what we have here, so on the left side, we have the teach pendant. So this is a live feed of the teach pendant. So you're going to see exactly what's going on the robot. And we're going to be able to go into a little bit more detail on how to program that kind of application. On the right side, we have the two USB cameras showing the robot. So these, again, are a live feed of what's happening in here. On the top camera, what we're going to see, so that section, as you can see, there's a tray with parts on it. These one, we're going to use the contact offset feature. So we're really going to use the force, the sense of touch of the robot to touch the tray and feel the position of the tray. Then we're going to be able to locate all the parts inside the tray and go pick them. On the bottom camera, so what we see here, there's a vise. So we simulate a CNC machine in here, and we place a tag on it. So we're gonna use the camera to read that tag. So we're gonna locate that vise in here. We're gonna take a picture of it, and then we're gonna be able to readjust all the waypoints and all the trajectory accordingly to that new position. So again, as Tyler mentioned, so for this one, what we are trying to reproduce here is, let's say you have one robot that is moving from one machine to another, one CNC to another. You could use, instead of having like hard bolt to fix your robot into the ground and have a perfect precision on it, you could simply place that tag on the CNC machine. The operator will move the robot on his cart, place it in front of the machine as precise as possible, but there will always be a little gap, a little offset from the previous one that we've teach all the waypoints. So it's going to be humanly precise, if I can say. Then the robot will take a picture of the tag, and then from there reorient all the waypoints automatically from there. So as a setup, it's a really easy and fast to change setup over time. So as for the hardware, as Tyler mentioned, in the machine tending kit, we have the two grippers, as we can see in here, the dual gripper with the camera in here. At the moment, since with that situation, when we came at home with all the stuff that we can grab that day, so I didn't have two ND gripper. So I have one ND gripper on one side, which is IP67, so that's the one in the machine tending kit. Because mainly of the IP67 certification. But the other one that I have is the two-finger gripper, so a 2F85. This one is not IP67, but for the demo that I'm gonna have today, it's working perfectly. So if we jump to the program, so I'm just gonna press play and show it to you. And then we're gonna be able to go into the program into more details. So the gripper are activating. We are ready. So now we're doing the contact offset feature. So we are feeling, we're touching the edges of the tray to locate it. So right now the two first touch here are to know the orientation of the tray. So that's why the two touch are on the same side. Then we're gonna do a third one, which is gonna give us the translation. And with these three touch, we're gonna know exactly where the tray is on the floor right now. So we can pick the part. Then we move to the second station, which is the simulation of the CNC machine. So we take a first picture of the tag pretty far away to have a big field of view. Then we go down and take a second picture where the tag is pretty big in the picture. So we have way more pixel out of the picture with the tag. So we are way more precise at the same time. And then we are able to locate exactly where the device is inside the CNC machine. So if I play it back, but I'm gonna move a bit the tray, and then move a bit the same way device in here, and press continue. So right now what I'm doing, we are doing the contact offset and the visual offset at each pass, but normally keep in mind that these steps will only be done at the beginning of the program, so it's going to be done only once. And from there, the position of the tray won't change. We're going to know it for sure. And then the position of the device won't change again, and we're going to know it at the end. So it takes a little bit more time to at the first when you start a program, but from there, everything will be set up. So as you can see, we fill our way into the tray. We knew the new position of the part, and then we're gonna do the same thing with the vice. So we take a first picture, take a second picture, and then go pick the part inside of it. So it's the same program with different position, and with the contact offset feature and the visual offset feature, we are able to locate these new position. If we go into a little bit more detail into the program, so I can start with the gripper really quickly. So the first step in here is basically open the gripper. So it's just to show you guys the software that Robotiq is doing. So as you can see in here, when we install the Robotiq software, everything can be done into the teach pendant of the UR robot. So there's no external programming. So as you can see here in the UR cap, so these are all the nodes created by Robotiq. So there's a few of them. One of them is the gripper in here. So when we enter a gripper node, we have this one, so we can edit action. And as you can see, we can edit position. We can edit the speed and the force really as desired. For this specific action, we just click the fully open position for both grippers. So we make sure that both grippers are open before we start the program. From there, we got the first part, which is the fine contact offset. As you can see, the first one, when we hit orientation, so you can see, okay, we have the multi-point, so these are transition and approach position. We got the fine surface feature, which is basically the sense of touch of the robot. That's where we're gonna go into a direction and wait until we feel a surface. As you can see, there's two of them inside the orientation, so that was the first one. And then we have the translation in here, which is basically the same, but we only have one touch to feel the translation. So if I create a new one, let's say right from there, it's going to be on top here. So fine contact offset. So if we start from scratch, just to show you how it's done, we teach a sequence. We select a feature. So right now we can select anyone. So there will be the two options, so either translation or orientation. What we've done for that specific demo, so we've first chosen the orientation. And as you can see, it takes a few seconds, but everything will be filled out automatically. So all the touch, the fine surface, transition, approach position, everything will be in there. And then you're just gonna have to save some waypoints from there. So it should appear. And from there, so I don't know what, okay, here we go. Sorry, I didn't click on it the first time. So we got, sorry about that. So once we've done with the orientation, we're gonna just click on the translation and both of them will appear like you can see in here. So orientation and then translation. From there, I can move the robot right now. Okay, I just saw the, here we go. So we got the orientation in here. So as you can see, everything is yellow. So that means you need to do some action, but everything is basically filled out. So you're gonna have to teach a transition to point and approach position. What I wanted to show you is the fine surface feature. So that's a dedicated node to do the fine surface action. So as you can see, you can select the direction as you wish. So there's any direction that you want in there. So you can perform that in any way you want. And then in the advanced parameter, so as you may notice during the demo, I was going pretty slowly, but that's because my my train here was pretty, so it was slipping on the floor. So that's why I've put the yellow mat just to give a little bit more friction. And I was going really slowly to make sure it's not moving while I'm doing the fine surface action. But again, you can adjust that really as you wish into that specific node. So as you can see, we have the motion speed, so 5 millimeters per second. We got stop condition as well. So let's say you travel at the moment it's 100 millimeters, but let's say you travel more than 100 millimeters, there will be an error condition. So if I select this one, it's going to be if function inserting into the program. So if I travel more than 100 millimeters, that means something wrong. And then there's the force threshold. So this one if I feel 10 newtons, that means I sense a surface. And that's what I want to do right now into the contact offset. So again, everything is really easy to configure. It's just numbers that you change. So there's no external programming. Everything is done via the teach pendant. From there, at the moment, there's another orientation, but if we jump into the other section, so this one is the node to apply the contact offset. So basically you can do the touch before the program start. And from there, you know exactly what's gonna be the new position. And when you're ready to use it, you just enter that node, apply contact offset, and then everything below that will make sure that you use the new position of that tray. From there, we jump to the second section, so the visual offset feature. So we got in here, find visual offset. So again, this is a node already created within the Robotiq software. So find contact offset. So as you can see, this one, it was the first picture where we were pretty far away from the tag. So we wanted a big field of view to make sure that we have a large range if the device was moving a lot. So we locate the tag, and from there we move straight on top of the tag. So that's where we apply the visual offset. And then we apply the move in here where we're gonna be always on top of the tag. And then we do a second picture. So that's, I would say, the best practice to make sure that you have the highest precision as possible. So the second picture, as you can see, we got way more pixel of the picture with the tag on it. So we get way more precise out of it. The precision, I would say, a little, in the best case scenario, you're gonna be in a little less than a millimeters. So maybe 0.8 millimeters, that's gonna be the best case scenario at the moment. So we can get pretty good precision out of it. And then we apply the contact offset, and that's where we're doing the moves to go pick the part, pick the finished part in the CNC machine, then place the raw part, and then move back the finished part somewhere else on a table, for example. So if I go back, so I'm just gonna load back the program and play it to you again, so you can see, you will have a better idea of what's happening exactly. So the program is loading. Okay, here we go. And again, when it's gonna be starting, I'm gonna place back the part. And again, I'm gonna move back this one a bit. And we can even do a 3D dimension location. So let's say I'm putting this part in here underneath. So as you can see, there will be a level in the CNC machine. So the visual tag is really a 3D orientation. So when we take the picture of the tag, we are able to locate all axes in there. So right now we're doing the contact offset again. So there will be the two first touch. And as you can see, that's why I'm going pretty slow at the moment. So it was really to make sure the tray remained fixed when I touched it with the gripper. So now we know the orientation. Then we jump to the translation. Again, with these 3 points, we're gonna know exactly where the tray is on the floor. So first picture, second picture of it, closer to get more precise. And as you will see, we're gonna locate the new vice position in the 3 axis actually, and we're gonna be able to go pick the part accordingly. So Kel, that was pretty much the demo I wanted to show. I don't know if there was some question into the chat or if maybe Tyler, I forgot something.
At this point, there have not been any questions.
No, I think you did a fantastic job with the demo. And I think, maybe we can talk a little bit about how these actually translate to a real world deployment of a CNC machine tending cobot. So first and foremost, the contact offset feature that Mark was doing. And Mark, would you mind just letting that program run again in the background while we're talking?
Sure, no problem.
the contact offset that the robot is doing doesn't have to be done on every single cycle. Once it's been set up and it knows where its tray of parts is, that robot will basically unload and machine every single one of those parts on the tray before you have to have an operator interact with it, whether it's swapping in a new tray or changing trays in the drawer system, etc. The same thing is true with the visual offset that's taking place, the camera taking a picture of that tag. Once the robot knows where it is in relation to the machine, the vise, the tray, etc., whatever it is it needs to see, it's going to reference all of its moves from there, and it's only going to have to scan that tag once. So while it may seem like this might be something that will inhibit cycle time, in all reality, what we're showing you here is just really an ease of use and an ease of setup operation. These tools allow you to take your cobot and run it on one CNC machine in the morning and then switch it over, run on a different machine in the afternoon. And the next day, maybe you don't use your robot at all. You're free to basically look at your robot as a tool rather than a fixed piece of automation hardware.
Great. Well, I have been monitoring the chat window so far. There's been no questions that have come up from anyone. If there's anybody out there that has a question or would like to get more details on a particular line of the code and how it was processing, please post that up now and we'll be happy to take a look at it. Hey, Tyler, while I've got you, what other resources does Robotiq offer on your website for people who want to learn more about how to use not only your products, but how they work with the UR robot platform as well?
Yeah, absolutely. Good question. So basically our website is the best place to find any Robotiq resource. That's where we have our product information, where we have case studies, our ebooks, our e-learning, everything is there. So let's say you're interested in the 2-finger 85 gripper, for example. If I go to that product page on the robotiq.com website, that's going to show me all of the technical specs. I can download a product manual if I need it. I can download software if I need it. And it looks like Mark Antoine's actually going to go to that right now. So I'll have him do that in the background while I'm talking. So also on that 2-finger gripper page, you're also going to be linked to a case study or an application, for example, of a real world deployment with some feedback from a real customer on how they use this product to help achieve whatever their automation goal was. So these resources are available for every single product. In addition to that, Mark, could you go to the ebooks portion of our website?
Yes.
So on the ebooks page, actually that's the one right there that I wanted to point out to everybody. The Robotiq Machine Tending, How to Improve CNC Machine Production Guide. Now this is a free ebook that's available for download on our website. What it's going to do is basically walk you through all the steps from the design, the integration, and the operation phases. And what that is doing is taking the lean robotics approach to machine tending. So if we go to the lean robotics ebook as well, that's another great resource from Robotiq that is focused not just on machine tending, but really, if we go to leanrobotics.org, this is a how-to guide for deploying a cobot anywhere, whether you're doing machine tending, palletizing, a pick and place operation, sanding, no matter the application. This step-by-step guide is going to help teach you really the best steps to ensure that you're efficiently deploying your cobot and that you're saving as much time and money as possible.
This is a great book and a great resource that we've taken advantage of and a lot of our customers have. And I want to make everyone attending today aware that if you were to email ACS at info@acs-ga.com or reach out to your local account manager, just let me know that you would like a copy of this book. I have them in stock at our office and would be very happy to ship one out to you at no charge. You can, of course, download it here as an ebook read, and it is available on Audible if you would prefer to listen to it while you drive that way. But this is a great resource. I would recommend getting a hard copy to be able to make notes in it and be able to add your own comments to the book as you go through it, because it's one that's really full of good, useful tips and information.
Precisely. Now, finally, we'll cover the e-learning platform again. Obviously, as we are all in kind of unique work environments, some of us are still at the factory doing some essential production. Some of us, like myself, are working from home. This is potentially a great opportunity to really do some studying and some learning about your next automation project and come back ready to hit the ground running with some new ideas once we all get back to work. So again, the course categories are broken down by lean robotics, by application, or by product. So if we go for a product specific example, if we go products and then click the two-finger adaptive grippers, that specific course will take us from a basic introduction to what an adaptive gripper is, all the way up through almost like the graduate level advanced programming. And so just like, elementary school, middle school, high school, there's a progression through the school system. Our e-learning platform is set up the same way. If you just need to come back to the e-learning course for a refresher, you learned something a few months ago and it kind of slipped your mind, you're welcome to go in and kind of look at the index and then go straight to the lesson plan that you need in order to refresh your mind. So if I'm using a wrist camera, for example, and I don't quite remember exactly how to do color validation, if I go products, wrist camera, I'll be able to find that there in my index.
Awesome. What a great resource you've got there, Tyler.
All right, and thanks to my magical assistants here, Mark Antoine, as well, following right along with everything I'm saying. So, folks, I know we presented a lot of information to you this afternoon. Some of it might seem a little bit overwhelming, but the message we really want to convey here is that we're here to help you deploy cobots on your own, but not alone. ACS is a fantastic resource. Universal Robots is a great resource. Robotiq's a great resource. We're all here to help make sure that you're able to deploy cobots successfully and, keeping with the lean robotics theme, help you start production faster. So I'm always available to reach out by call or email. We can share my contact information after this webinar is complete. Same with Kale, same with Mark Antoine.
Yep. Thank you so much, Tyler and Mark. To everyone listening today, if there are folks within your organization that did not get the chance to participate this afternoon, we are going to be posting this on our YouTube channel. So you can find it on YouTube at Advanced Control Solutions. We've got our entire webinar series, what we refer to as our web workshops, that we have been posting during this time. So there are multiple videos already there that cover various technologies that we represent. Our automation specialists are ready to help out, and Tyler and the automation coaches like Mark are available at Robotiq. So please feel free to reach out to us, info@acs-ga.com, or if you already know your local account manager, you can reach to them, or as always, reach directly to Tyler, and ask anything that you need to. So thank you so much for attending. We do appreciate your time, and stay tuned to our website for other episodes in our web workshop series that we're going to have coming up, because we will have Robotiq back for another session. Thank you, guys.